Hello everyone, welcome to my channel. In today's video, I want to show you how to validate DICOM transfers to ensure data integrity after DICOM transfer. This is a deeper dive following my previous video, the Mastering DICOM Send and Receive Step-by-Step DCMTK Toolkit for storescu and storescp. In today's video, I will also talk a little bit about the DICOM transfer syntaxes as well as FDA approval insights if you want to develop a medical device using these DICOM tools. Now let's dive right in. I will show you how to use Python code, specifically the PyDICOM, to compare the original and the transfer DICOM files. This code supports the tag comparison for the CT images or medical images in general, RTDOSE object, RTSTRUCT object, as well as RTPLAN object, which are commonly used in radiation therapy. We can see it listed all the tags, and this is the before and file 2 is the after. Look a deeper dive into the transfer. One is the implicit VR Little India, and that is the one we saw in the original file. And the second common one is implicit VR Little India. And we see the difference between these two is the explicit VR has the VR is explicitly specified for each element, while this implicit doesn't have this element. And what is VR? VR is the value representation. For example, for a patient name, the value representation is PM. And there are other VR representation, such as AE represents for application entity, AS represents for age strain, etc., etc. So both the first one and the second one, they use Little India. However, the explicit VR has this additional element, and this is actually more common than implicit VR for interoperability. And you can also check my previous video when I tried to extract DICOM headers using C++ code. This one straight reads the byte information without any external library. And over there, I also mentioned for the DICOM files, there are mainly two types. One has VR, one doesn't. And over there, I call it type 1, type 2, because if you have a VR element, when you get a tag, you will go straight to read the value length, versus you have the VR tag, have the VR element after you read the tag, you will read this value, so you will skip some byte, then go to get the value length information. So the third one is also explicit VR, but it's Big India. Big India is nothing that it puts the most significant byte first. So this one is actually really used in modern systems. It was used in older systems, so we don't need to worry about this for now. So we see in our previous before and after, this transfer syntax changed from implicit VR to explicit VR because the system thinks explicit VR is more common. So why is that? So this is a little description about Little India and Big India. Little India stores the least significant byte first, versus Big India stores most significant byte first. And the Big India is used less frequently now. So that's why I still include these slides here. So the reason we see when we use storescp and storescu, the transfer syntax changed. This is mainly due to how the DICOM association negotiation is implemented in the DCMTK storescu and storescp tools. So when the two DICOM applications communicate, the storescu first proposes some supported transfer syntaxes, and the storescp accepts the first common syntax from the list. The default proposal by the DCMTK storescu is to send the DICOM. It proposes explicit VR Little Indian first, if we don't specify otherwise. This is the default. And then it will propose the explicit VR Big India, but this may not be even supported. This depends on your machine configuration. So basically, it will propose explicit VR prior to implicit VR. And when the storescp receives, it sees the storescu first propose this explicit VR Little India, and it is one of the syntax it can accept, so it accepts right away. That's why we see the file changes the transfer syntax tag after transfer. So the reason the storescp and storescu they prefer explicit VR is because, remember, the VR is additional tag element, so that will make it easier to pass and supports more value representations. So it increases the readability across different systems. That's why it is preferred. And DCMTK favors explicit VR Little India unless specified otherwise. And the behavior of storescp is to accept the first common syntax proposed. And in the example I showed earlier, it overrides the original transfer syntax because it also supports the explicit VR Little India, which is the first one proposed by storescu. So then how do we, if we really want to keep the transfer, whatever the initial transfer syntax, we can first check what the transfer syntax is in the original. And if it is explicit VR, then we don't need to do anything because the storescu by default will propose that syntax. But if we prefer to keep the original implicit VR, and in order for the DCMTK DICOM transfer to keep this transfer in syntax, when we use the storescu, we add XI option. And let me also show you the DCMTK website. And here they have a list of proposed transmission transfer syntax. So explicit VR, implicit VR, they are just some of the few transfer syntax support by it. We can see here it also supports JPEG, lossless, lossy, etc., which are not commonly used, at least in radiology and radiation therapy. So we will stick with this for now. And now let me show you in the storescu minus XI option. So I am specifically asking the storescu to propose the Little India implicit VR. And here now we see after we use that option, it keeps the same transfer syntax. So next, I want to talk a little bit about the FDA insights if we want to validate this DICOM tool. So because the DCMTK is an open source toolkit, and the PyDICOM is also open source. So the way I compare is not enough if we want to prove for FDA submission. But the PyDICOM, it has its merit because we can batch processing all the files, and we can easily output them to a report. So this we can look at all the tags, different file types, and like very quickly. But this is the initial DICOM comparison. How do we link to the commercially validated tools? So one way we can do it is we can compare the PyDICOM output for a selected files with some commercially available software, such as a planning system or such as the MIM system. Or if you are just dealing with images, then you can use some commercially validated PAC system. But here, the key is the cross-validation. So basically, you're using PyDICOM, you can batch processing a lot of files, but this is not enough. And to establish the link to a commercially validated tool, you just compare selected files using PyDICOM versus a commercially available system. And therefore, this will establish a link between your initial validation with the final validation. And of course, documentation is very important for FDA. You need to have the design requirement document. You need to have the verification plan. Then you will have the verification validation reports. You will also have a risk management plan, etc., etc. And you may also wonder, what if it's a very, very first DICOM device that we don't have any commercially available system to cross-validate? So although we don't need to worry about this now, but just a little extra thinking. So in that case, you will need to manually inspect the raw bytes. And that is, I have a related video of unlock the DICOM data using C++ code where you don't use any external library, such as here, the PyDICOM is an open source library. But this example with C++, we are strictly examining the raw bytes. And by doing that, you compare that with the DICOM standard. And that is the raw validation if you don't have any commercially validated system to compare. So that's all for today. Thank you for watching. Like, subscribe, and comment. I will see you next time. Bye.